Hello students, myself Prof.Gorane. In last few lectures we have studied theory part of chapter Electromagnetic Induction from 12th science. Now today we solve some numericals based on this chapter. First numerical is a horizontal wire (20 meter) long extending from east to west is falling with velocity of 10 meters per second. Normal to the Earth's magnetic field of 0.5 into 10 raised to minus 4 Tesla. What is the value of induced EMF in wire? See here, a horizontal wire 20 meter long, that is given, our given data is L is 20 meter, extending from east to west, falling with velocity, that is V, 10 meter per second. Normal to the Earth's magnetic field means that theta is 90 degree, and induction B is 0.5 into 10 raised to minus 4 Tesla, and we have to find EMF induced. Such problem carries 2 marks, half mark for the correct formula, half mark for the substitution of the values, and 1 mark for correct answer with unit. We know EMF induced is BLV sin theta. BLV sin theta. Simply substitute the values. B is 0.5 into 10 raised to minus 4. L is 20. Multiplied by V 10 into sin 90. This sin 90 we know it is 1. Sin 90 value is 1. This is 1. Now 20 into 0.5, that is 10. And this minus 4 plus 1, 10 raised to minus 3. That is 10 into 10 raised to minus 3. As it is EMF, unit is volt. 10 into 10 raised to minus 3 volt, or we call it as 10 raised to minus 3 volt is 1 millivolt. So it is 10 millivolt. In such problems or numericals, marking scheme is very simple. Correct formula, you will get half mark. Correct substitution, you will get half. Correct answer with unit, this or this, you will get 1 mark. If unit is wrong, half mark will be deducted. So this is the simple marking scheme for such numericals. Now we see second one. The value of mutual inductance of 2 coils. The value of is 10 millihenry. if the current in one of coil changes from current changes from 5 ampere to 1 ampere in 0.2 second. Calculate the value of EMF induced in the other coil. Also calculate the value of induced charge. Through the coil if its resistance is 5 ohm. Very simple problem. Firstly, see the given data. The value of mutual inductance of two coils is 10 millihenry, that is capital M. 10 millihenry, or it is 10 into 10 raised to minus 3 Henry. If current in one coil changes from 5 ampere to 1 ampere, suppose I1 is 5 ampere, I2 is 1 ampere in time delta t, suppose that time is 0.2 second. Current changes from 5 ampere to 2 ampere in 0.2 second. Calculate the value of EMF induced and induced charge if resistance is 5 ohm, R is 5 ohm. We have to find value of induced EMF, that is E, and also induced charge, we denote it as Q. We have to find E and Q. Now we know change in magnetic flux delta phi. Change in magnetic flux delta phi is M into delta I, mutual inductance into change in the current. Current changes from 5 ampere to 1 ampere. Initial current is 5 ampere. Final current is 1 ampere. Now M we know, that is 10 into 10 raised to minus 3. And change in current is 1 minus 5. That is minus 4. Minus 4 into 10, 40 into 10 raised to minus 3, minus 40 into 10 raised to minus 3, or minus 4 into 10 raised to minus 2 Weber. This is the change in magnetic flux, that is minus 4 into 10 raised to minus 2 Weber. Now we have to find the EMF induced. And we know EMF induced is magnitude of d phi upon dt or delta phi upon delta t. Magnitude delta phi upon delta t is the EMF induced. But here this is minus 4 into 10 raised to minus 2. If we consider its magnitude, that will be 4 into 10 raised to 2 minus 2 divided by delta 2 is 0.2. 4 into 10 raised to minus 2 upon 0.2. By solving this, we get that EMF as 0.2 volt. So this is our first answer. Very simple calculation. We can solve it easily, and that value is EMF is 0.2 volt. Now we have to find induced charge also. See here, this is our first answer, induced EMF. Now induced charge. Induced charge, we find induced charge is current into time. Suppose delta Q is I into delta T, because I is dq upon dt, so charge is I into delta T, but we also know I is E upon R into delta T. This EMF is 0.2 volt divided by R is 5 ohm into delta T is that is 0.2 into 0.2 divided by 5. This is 4 into 10 raised to minus 2. This much part is 4 into 10 raised to minus 2 upon 5. 0.8 into 10 raised to minus 2, or this is 0.8 into 10 raised to minus 2, or we call it as, if we adjust the terms, 8 into 10 raised to minus 3 coulomb. 8 into 10 raised to minus 3 coulomb, but this is nothing but millicoulomb. We write it as 8 millicoulomb, or simply write it as 8 into 10 raised to minus 3 coulomb. Then next one numerical, we see two more numericals based on the electromagnetic induction. Formula carries half, substitution half, and correct answer with unit 1. Very simple marking scheme. Simply write the correct formula, you will get the half. Substitution and other things, you will get the remaining marks. An EMF of 96 millivolt is induced in the windings of coil when the current in the nearby coil is increasing at the rate of 1.20 ampere per second. What is the mutual inductance? That is, we denote it by M, mutual inductance M of the two coils. EMF of 96 millivolt. So E is 96 millivolt given. That is 96 into 10 raised to minus 3 volt. 96 millivolt is induced in the winding of the coil when current in the nearby coil is increasing at the rate of 1.20 ampere per second, that is di upon dt. This rate of change of current is 1.20 ampere per second, and we have to find the mutual inductance between the coils. Very simple formula. Mutual inductance is E upon di upon dt. E upon di upon dt, we know, is, this carries half mark, is 96 into 10 raised to minus 3 divided by 1.2. This ratio is 80. 96 upon 1.2, that is a simple ratio. 80 into 10 raised to minus 3, as it is a inductance, unit is Henry. 80 into 10 raised to minus 3 Henry, or we call it as 80 millihenry. Because 10 raised to minus 3 Henry is 1 millihenry. And now we see one more numerical based on this chapter. The primary and secondary coil of transformer each have an inductance of each have an inductance of 200 into 10 raised to minus 6 Henry. The mutual inductance between the windings is denoted by M. Mutual inductance between the windings is 4 into 10 raised to minus 6 Henry. This is the mutual inductance between the windings. What percentage of flux from one coil reaches the other? Very simple problem. Reaches the other. See here given data first. Two coils are there. Primary and secondary coils of transformer each have inductance of 200 into 10 raised to minus 6 Henry. That is the self inductance given. Self inductance L is 200 into 10 raised to minus 6 Henry. 200 into 10 raised to minus 6 Henry. Then mutual inductance is also given. Mutual inductance we denote it by M, and that is 4 into 10 raised to minus 6 Henry. 4 into 10 raised to minus 6 Henry. What percentage of flux from one coil reaches the other? The percentage of flux transfer, this percentage is given by M upon L into 100. Simple formula. Here M is 4 into 10 raised to minus 6 L is 200 into 10 raised to minus 6, 4 into 10 raised to minus 6 divided by 200 into 10 raised to minus 6 into 100. This is 2. By solving this, we get simply 2. 4 into 100 is, this 10 raised to minus 6 get cancelled. This is 400 upon 200 is 2%. So the percentage of flux transfer is 2%, or 2% of the flux from one coil reaches the other. So this is about some numericals from electromagnetic induction. We stop here. Thank you.